Hello all, welcome back. We are going to look at the problem called as sorting. First, as we said, we need to clearly understand what is sorting problem, what is the input and what is the output expected of um, from a sorting programmer, right? So I'm going to write the input. So input is an array of integers. Okay, so it's an array of elements, but it can be an array of integers or strings, for example. In our mostly we will be looking at array of integers. In this lecture, we will look at various types of sorting, and you will see that I mean sorting can be applied to not just an array of integers but also array of strings also. But the sorting types of different sorting algorithms we are going to look at, we will just concentrate on sorting integers. Okay, so that's you can clearly you'll be able to see that the same sorting algorithms can be extended to work on over strings or any other structures. Okay, so let's say as sorting as an input, you're given an array of integers. Okay, and output is so the output is going to be a sorted array, sorted in ascending order. This is the sorting problem. You're expected to, and we will mostly have the same array will be the numbers in the same array, the integers in this array, the same array will be exchanged or swapped, and that same array will be returned as a sorted array. That's what how we will write our sorting algorithms. Right now, before we get into specific sorting algorithms, let's go and do a brief overview of why we require sorting and the different types of sorting, etc. First of all, have you used an Excel sheet or a Google sheet, or if you are using Mac, something called as numbers? So these, if you have used an Excel, the Excel application, you're highly likely that you have used sorting there, right? So why you would have used, if you have a list of some, what are the typical things you will be using an Excel sheet for? So for example, like me, since I'm going through your course, for example, I will have all your details, right? Your names. So my Excel sheet will be something like this. There will be a name and your roll number, right? Your assignment mark, right? So these are the things will be there. This will be my Excel sheet, and there will be names here. I'm going to write some arbitrary names here. So let's say okay. So I have written some names, and then there will be your roll number. Um, let's say so some numbers here, right? And your marks. Right, so this will be something in my Excel sheet, and so something which will always come up is, okay, I want to sort these rows in ascending order of your names. Okay, so I would want Arjun first, and then Rohit, then Shyam, and then Vishal. Right? So this is something you can in the Excel sheet. You just have to go and click here and sort it. So it's as easy as that. Or I would have wanted to sort it according to the assignment marks. So the top assignment, so 20 should come here. So like Vishal and 20 should come here, etc. Okay. So all these kinds of sorting will be. This is kind of very natural when if you are using an Excel sheet program. This is something you just, without even thinking, you would be you would have used sorting. And so that's one thing, and it comes up in many other. So you have written JEE exam, and how are the ranks? How did you get your ranks? Because you got your rank because all of you have been sorted according to your marks you have got, and in the sorted order you have been assigned a rank, right? So a sorting has been behind the JEE portal, right? Inside the JEE portal, a sorting of all the JEE applicants has been done there according to their marks. So sorted according to their marks, they have been sorted, and a rank being given based on that that sorting, right? So, and you can. There are innumerable places where sorting will come up, and you will be throughout your engineering program, you will be seeing a lot of other applications of sorting. Okay, so this is we are coming back to sorting, right? We looked at some applications of sorting, and now let's look at the different types of sorting. So there are, in general, you can think of sorting as there are two types of sorting. Okay, and let me just note that down. So in general, there can be two types of sorting. One is called as internal sorting and external sorting, right? What are those sorting? So in internal sorting, you are going to assume that your entire array, this array, okay, this array of integers is in your RAM, okay, is in your memory. So let me write. So the array in RAM. On the other hand, what about external sorting? In external sorting, the arrays can be huge, and therefore this array can also be in your hard disk. So this array can be the array can be in your hard disk in an external sorting. We will be in this course, we will be looking at internal sorting, and we are going to assume that even though our arrays, we are going to look at our arrays as going to be very huge and big and large, but we are going to assume that that entire array is going to be in our memory, right, in our RAM. So that we are going to go ahead with that assumption, and we're going to skip this part of external sorting, and there's a sorting called as merge sort, which you will learn here, which we will learn as part of the internal sorting. And merge sort can be extended to, it can be extended to be used as an external sorting algorithm. Okay, right. And in internal sorting, what are the kind of things we are going to see in internal sorting? The kind of sorting algorithms we are going to look at are some example sorting. So the main sorting algorithms we are going to look at. So we are going to concentrate on internal sorting, and let's look at the kind of sorting algorithms we are going to look at. what are the sorting algorithms we are going to look at? So the kind of things, the sorting algorithms we are going to look at are, let me list them down. Uh, Okay, so these are the 5 algorithms we look at: selection sort, insertion sort, bubble sort, quick sort, and merge sort. Right. And while we look at these algorithms, and we are going to analyze the worst case running time of these algorithms, and you will notice that these algorithms are going to work in order of n square. These are relatively simple sorting algorithms, something which you can think of it as a natural sorting algorithms. For example, this insertion sort is something which you do very natural, something which if you are not taught sorting, if you're playing cards, you would have, and you want to sort your cards in some order, then you would have probably used insertion sort. Okay, so these are relatively simpler sorting algorithms, and they're going to take order of n squared in the worst case running time, and also in the average case running time they're going to take order of n square. What about quicksort? Quicksort in the worst case is going to take order of n square. Okay. On the other hand, in the average case, quicksort in the average case is going to take order of n log n. Okay. On the other hand, merge sort in the worst case is order of n log n, and the average case also order of n log n. Right? But in spite of that fact that merge sort in the worst case also order of n log n, that way it's better than quicksort. So this is something you can see, right? N log n is better than n square. In the sense it's faster than n square. So compared to quicksort, merge sort is better in the worst case. But quicksort is considered to be the best sorting algorithm simply because its average case running time is, even though they both have the same average case running time of order n log n, the constants for this n log n in quicksort are much smaller compared to the constants in the merge sort implementation of the algorithm. Okay. So the merge sort algorithm. So for that reasons, quicksort is considered to be the best sorting algorithm in that sense. Now, but there are also there are other advantages of each of these sorting algorithms. As I said, these are much simpler sorting algorithms. So what is an advantage? Easy to implement. If you want to just write a sorting program for a few you want to sort a set of some small set of numbers. You can use this. You can just write a sorting like this on one of these sorts, right? But if you want to sort a large set of numbers, then you will have to use these, right? One of these, and these are slightly complicated. And another property which you will notice is the following fact, that you should also always think is, are we taking extra memory for this sorting? Right? So do you want an extra array for the sorting purposes, or you don't want that? You can just play around with the input array while you sort. So that's called as in-place sorting. So in-place sorting. So in place sorting, you don't require extra memory. You just use the input array for your sorting purposes. And you will notice that these sorting algorithms are in place sorting, or these three. Quicksort is also in place sorting. On the other hand, merge sort is not in place sorting. Okay, you will have to use an extra array for merge sort for in place sorting. And but there is a workaround for that. The merge sorter algorithm we are going to see will not be in place sorting. Now to avoid that, you will have to make the merge sort more complicated. We won't go into that. But okay, so there is a workaround, but in general, merge sort can be thought of as not in place sorting, right? Another interesting property of sorting is called as stable sorting. Okay, this is especially important where if you are going to implement a sorting algorithm in your Excel sheet, for example, you will have to implement a stable sorting. Now I will tell you what it means. Okay. Now, what is stable sorting? Okay, so let's go back to our Excel sheet analogy, right? So, or your okay, let's go back to your JEE analogy. You have JEE ranks. Okay, so I'm going to draw here some ranks here. Your marks for JEE. So you have 100. I don't know what. So I'm just writing some numbers. Okay, 123, 257. Etc. 75, etc. Okay, this is not in sorted order. I didn't intend to be in sorted order. These are some marks of some candidates. So your candidate names will be here, which I am not writing now. So this will be some information for the ranks, and there will be certain candidates will have the same marks, right? So there will be someone with 123, and right, and someone with 100 here. I'm just writing. Okay, and another information for the for a candidate is his or her date of birth. So this is marks, and okay, and in JEE ranking, date of birth is important. Why? I think in JEE rank, so there was this in some NEET net ranking. If so, there was this case where the first rank was given to one person because his date of birth was either bigger or smaller compared to the second rank, even though they both got the same marks. One person was probably an elder, and therefore he was given first rank, because that's the sorting algorithm they use. So if two people have the same marks, right, then you go to the date of birth and you are sorted according to the date of birth, right? And then that is used as the what is it? That's used as the you are ranked according to the date of birth. Okay, so that's what we also will have to implement it. So I'm going to assume that this is sorted according to the date of birth. Okay, so this is sorted. Okay, and now this is sorted according to the date of birth. And now I want to sort according to the marks, right? Now, if I want to sort according to the marks, I should not misplace this. So this means that, okay, so 123, these two 123s have to come together, right? This and this have to come nearby. But when I sort this 123 should be above this 123, right? Because this ordering between the same 123 should not be exchanged, because this guy's date of birth is better than this guy's date of birth, right? So I don't want to destroy that that sort. So I want to sort in marks without destroying the date of birth sort. So when I sort in marks, so let me call it x. This is x1 and this is x2, and this is y1 and this is y2. If these are the things, and when I sort the marks according to the higher marks above, if I'm going to sort this in a descending order, what I'm going to get is the following. The 257 guy comes first. then so 257 and something, this is the date of birth. Okay, so you want the sorting to be in this order. 257 comes first, and then the two 123s come, x1 has to be above x2. Okay, and when 100 comes, y1 has to be above y2, and 75 comes above. So this among the equal guys, the previous sorting algorithm, the array ordering should be preserved. So that is called as stable sorting, and we would require in Excel sheets and all, you would always prefer stable sorting, because you want to preserve the previous sort, for example. So which of these algorithms support stable sorting? Right. Let's check that. So okay, so stable sorting is right. Let me just tick mark which are stable sorting. Okay, so sorting algorithm which supports this kind of sorting is called a stable sorting, and you will see that bubble sort supports, merge sort supports, insertion sort supports, selection and quicksort does not support stable sorting. So selection and quicksort are not stable sorting algorithms, or the algorithms which we are going to see are not stable sorting. But this can also be modified to support stable sort. Okay, now but making it more complicated, right? Okay, so this is a brief overview of sorting algorithms, and we will now go and start looking at initially the simpler. So these are, as we said, internal sorting. We will go and start looking at each of these sorting algorithms, and that will be our course will end with after we go through all these sorting algorithms. Okay, thank you.